we will proceed to the line spectrum. So line spectrum is also called as atomic spectrum. What is line spectrum? It is a spectrum that contains discrete lines separated by blank areas, and each line corresponds to specific wavelength and also frequency. What is meant by the word discrete? So discrete here means a few sharp lines. It's like this. Sharp lines, huh? It is produced by excited atoms or ions as the electron fall back to a lower energy level. The radiation emitted is only at a specific wavelength and frequency. It means each line, this one line, corresponds to a specific wavelength and frequency. Dia ada certain wavelength and frequency. So how can this line spectrum form? First, the hydrogen gas will be filled into the gas discharge tube. This gas discharge tube. The discharge tube is filled in with H2 gas. Then, what is the function of high voltage here is to supply energy. Supply energy to this H2 gas in that discharge tube. Then what happened? H2 gas will transform into H atoms, hydrogen atoms. We know that one hydrogen atom contain one electron, right? So what happened when energy is supplied? Electron of the hydrogen atom will absorb energy. So the electron of the hydrogen atom will absorb energy. Then it will be excited to the higher energy level. The electron will be excited to a higher energy level. Once it has reached that higher energy level, it becomes unstable. It becomes unstable. So what happened? It will fall back or drop to the lower energy level. So, bila dia jatuh, it will emit or release amount of energy in the form of photon. It will emit or release energy in the form of photon. Then the photon, the light energy, will go through the slit, will go through the prism, then disperse into the line spectrum. That's why we'll produce the line spectrum, which each line will correspond to specific wavelength and frequency. So this is the example of the line emission spectrum of hydrogen atoms, which it is correspond to different wavelength and frequency. Again, how can that line spectrum form? First, we have to fill in the gas discharge tube with hydrogen gas. Then, what is the function of the electric spark? Is to supply energy for the hydrogen atoms. Electrons of hydrogen atom will absorb that energy, then it will be promoted from ground to a higher energy level. Once it reaches the excited states, which is the higher energy level, it becomes unstable, then it will fall or drop to the lower energy level. Then it will emit or release the light energy, or what we call photon. So this light energy or photon will pass through the slit and the glass prism. Then the light disperses into the spectrum, which we call it as line spectrum. So this spectrum consists of a few sharp lines. So what is this few sharp lines? Again, it is the discrete lines, which each correspond to different frequency and wavelength. So when the electric is passed through the sample of hydrogen gas, which is in that discharge tube just now, at low pressure, the hydrogen molecules will decompose to form the hydrogen atoms. The radiant energy or the photon will absorb by the electron of the hydrogen atom, causes the electron to move from lower to the higher energy level. The electrons are said to be at excited state, which it is very unstable. When electrons fall back to the lower energy level, the radiant energies, which is the photon, tenaga cahaya, photon, are emitted or released in the form of light. Each ball represents one photon with a particular frequency and wavelength. We will look at the Lyman series first. So what is Lyman series? Lyman series is the transition of the electron from n is more than 1, 2, and equals to 1. So any transition of the electron start from 2, 3, 4, and so on, which are n more than 1, 2, and equals to 1 here, is the Lyman series. So one transition from 2 to 1. So when the electron transit or when electron drops, bila electron jatuh, from 2 to 1, it will produce this first line. Produce the first line. So this is the first line. The first line is produced when electron drops from n equals to 2 to n equals to 1. Okay. How can this second line form? Is when electron drops from n equals to 3, 2, and 1. Third line, when electron drops from 4 to 1. The fourth line and so on, equals to 5 and 6 and so on. How can we read the line spectrum? Macam mana nak baca line spectrum? Is from the biggest space in between of that two lines. Okay, we will start. Kita akan start baca kita punya line spectrum is from the biggest space between the two lines to the smaller space. So how can we read the line spectrum? Is from left to right. It's like the arrow pointing to right. From this first line to this second line, this is 1 lambda. Okay, satu panjang gelombang. Puncak bertemu puncak. Right. What happened to the wavelength? From the longest becomes shorter from left to right until it is continuum here. What we call it as the term continuum limit. So when lambda is decreasing, lambda makin jatuh, what happened to the energy? Since energy and lambda is inversely proportional, so what happened to energy is increasing. Energy and frequency is directly proportional. As the energy is increasing, what happened to frequency? Frequency will also be increasing. So that's why we have this. When energy is increasing, it will be increasing as well as the frequency. But it is inversely proportional with lambda, so that lambda will be decreasing from left to right. Let us look at Balmer series. So what is meant by Balmer series? Balmer series means the transition of the electron from n more than 2 to n 2. Here. So any transition, let's say from 3 to 2, any transition of the electron. Electron drops from 3 to 2 or 4 to 2, 5 to 2, and so on. So any transition that electron drops from n more than 2 to n2 is what we call Balmer series. So that is how you describe Balmer series, which the transition of 3 to 2 will produce this first line, which means electron drops from 3 to 2. How about this second line? This second line is formed when electron drops from 4 to 2. So this is produced when electron drops from n4 to n2. How about this third line? Third line is produced when the electron drops from 5 to 2. So this is when electron drops from 5 to 2. The same goes. Refer to the note. We know that before we have learned that delta E equals to Hc over lambda. Right. So this means as the energy increasing, what happened to the lambda? Lambda will be decreasing. Lambda makin jatuh. How about frequency? Since frequency and energy is directly proportional, so energy will be increased as well as the frequency. Macam mana nak baca line spectrum? Is from left to right. Okay, boleh jadi juga from right to left. But macam mana nak baca? Refer to the space in between these two lines. So the biggest space between that two lines, dari situlah you start baca. Right, okay. So from left to right. What happened to lambda? Lambda mula-mula panjang. Right. Okay, then it becomes shorter. Kan, sampailah sini dia sudah tertumpu. Sudah tertumpu di sini. This is what we call continuum limit. Titik menumpu. Titik menumpu. Dia tertumpu kat situ dah. Tak boleh dah. Dah habis limit dah. Okay, then what happened to the energy? Energy is increasing as well as frequency. Well, how about lambda? Lambda is decreasing. Lambda is decreasing. Kan? Mula-mula dia panjang di sini. Lepas tu it becomes shorter here. That is Balmer series. Okay, let us proceed to patient, bracket and fun. What are these series? Lyman tadi, we know that the transition is from n more than 1 to n equals to 1. Lyman, right? Balmer is when electron drops. This is Balmer. Balmer when electron drops from n more than 2 to n2. Right? Okay. How about this patient series is when electron drops from n3 more than 3. N more than 3 to n equals to 3. Bracket is when the electron drops or the transition of the electron is from n more than 4 to n4. How about fun series? Fun series is when the electron transit from n more than 5 to n5. So this is how you calculate the difference in energy. Energy in final minus energy initial. Ini menjawab soalan tutor. Or if you are given the different energy level, what is your Ni? What is your initial energy level? What is your final energy level? RH masuk nilai from the front page is 2.18 times 10 negative 18 joule. Pastikan you ambil nilai yang 2.18 times 10 negative 18 joule since you have two Rydberg constant ini. So what are the region for each series? If it is Lyman, which we know that the energy level at initial is n more than 1 to n equals to 1 kan? N finalnya. Right. Okay. How about Balmer series? Balmer series is formed when the energy level is n more than 2 to n2. If patient, n more than 3 jatuh to n3. Bracket kalau jatuh kepada 4, while fun is when electron drops to n5. Okay, so spectrum region. Lyman is UV, ultraviolet. Balmer only is in visible region. The rest are infrared. These are the differences between line and continuous. Line spectrum, we know that it comes from the gas discharge tube, which contain that H2 gas tadi kan. Okay. Then what happened? Okay, this high voltage supply energy to the electron of the hydrogen atom. Then the electron of the hydrogen atom will absorb energy. The electron of the hydrogen atom will absorb energy. Right. Okay, then the electron will be excited to a higher energy level. It will be excited to higher energy level. When it has reached that high energy level, what happened? It will drop because it becomes unstable at higher energy level. It becomes unstable. The electron becomes unstable at the high energy level. Then it will drops or emit. It will drops to the lower energy level. Then masa dia jatuh itulah dia release energy in the form of photon. Release energy in the form of photon. Dia release tenaga cahaya which will go through this slit, will go through this prism and disperse as the line spectrum. What is this line spectrum? Line spectrum contain the discrete lines. What is discrete lines? It means contain a few sharp lines, which each line correspond to certain wavelength and frequency. Wavelength and frequency. How about continuous spectrum? It is a spectrum that contains continuous band of light radiation of all wavelength, which the source is white light or sunlight here. Cahaya putih, Cahaya putih, which then it will go through the slit, then go through the prism and disperse is like rainbow colors here, which it is continuous, bersambung tanpa putus. No blank area in between. How about this? Separated by blank area. Because it has two lines here kan. So it is separated by blank area. You are given Paschen series. What is meant by Paschen series? Paschen series is when the transition of the electron from n more than 3 to n equals to 3. Right. Okay, sekarang ni macam mana kita nak baca line spectrum? Is from right to left. Kan, daripada jarak yang lebih besar here between A and B to jarak yang lebih kecil between D and E. Right, so kita baca, tadi kita baca from left to right. This time we read it from right to left. Okay, so how can this first line form? This is your first line. This first line form when the transition of the electron is from n more than 3, which is n4. n4 jatuh kepada n3. n4 jatuh to n3, the electron drops from n4 to n3, will produce this first line, A. B, this is a second line, which means the electron drops from n5 to 3. This is from 6 to 3, 7. So line E is from 8 to 3. Each of the line in the Paschen series corresponds to the longest wavelength. So longest wavelength yang mana satu is A, the longest wavelength, because from right to left, what happened to the wavelength? Semakin pendek. Right, semakin pendek. So the answer is line A. Let us look at ionization energy. What is ionization energy? Ionization energy is the minimum energy required. So minimum energy required to remove sebanyak mana? Sebanyak 1 mole of electron. To remove 1 mole of electron from 1 mole of gaseous atom or ion. So 1 mole of gaseous atom remove 1 mole of electron to form 1 mole of gaseous ion. Since energy is needed or energy is required, that's why we have that delta H or enthalpy is positive joule or positive kilojoule, means energy is absorbed. The hydrogen atom is said to be ionized when electron is removed from its ground state. So the ground state here is referred to n equals to 1 to n equals to infinity. Means kita campak terus electron from n1 to n infinity. Which at n equals to infinity, the potential energy of electron is 0. Here, no more attractive force of attraction by the nucleus towards the electron. The electron is free from the nucleus. In Lyman series, the frequency of the convergence of spectral lines can be used to find the ionization energy of hydrogen atom. IE means ionization energy. The energy needed or required to remove 1 mole of electron from 1 mole of gaseous atom, which is gaseous hydrogen atom. H is the Planck constant, while V is the frequency at infinity. The successive line becomes closer. What does this mean? Successive line itu bermaksud garisan yang berturutan itu, kan ke dia menjadi semakin rapat here. Kan? Ni, ini kan makin rapat. Right? So the successive line yang berturutan itu becomes closer to the previous until it forms continuum. It's like this. Dia macam bowl line here. Dia macam bowl line. Bowl line. Because as it far from the nucleus, the energy difference between two successive levels becomes smaller. Right? Okay. So from this first line to this second line, we know that the lambda is the longest. Kan? Ni lambda is the longest. Then it becomes shorter until it is convergence here, menumpu di sini. Kan? So what happened to lambda? Lambda is decreasing. From this formula, delta E equals to Hc over lambda, and delta E equals to Hv, right? When lambda is decreasing, bila lambda makin pendek kat sini, right? Okay, when lambda is decreasing or becomes shorter, what happened to the energy? Energy is increasing, right? That's why we can see here energy is increasing from left to right. Frequency will be increasing as well as energy. Why? Because energy and frequency are directly proportional. So energy will be increasing as well as the frequency, but it is inversely proportional with lambda. What is this frequency at infinity mean? This means the electron of the hydrogen atom has been ionized, sudah terkeluar at n equals to infinity. So this is referred to the frequency at infinity. Means the electron has been removed from n equals to 1 to n equals to infinity. So this is referred to the frequency at infinity. When we go back to the definition of ionization energy of hydrogen atom, which the ionization energy of the hydrogen atom is referred to the minimum energy required. Kan? Minimum energy required to remove 1 mole of electrons from 1 mole of gaseous hydrogen atoms at the ground state. Means kita nak campak keluar the electron from N1 campak terus to n infinity. Means the energy level at initial is n equals to 1, while energy level at final as n is n equals to infinity. When we use this formula of delta E equals to RH in bracket 1 over Ni square minus 1 over Nf square, so RH will be 2.18 times 10 negative 18 joule in bracket 1 over 1 square, because the initial is n equals to 1, right? Minus that Nf square, which means the energy level at final is infinity. So infinity square. You insert, then you calculate what is your delta E is this. Sebab 1 tolak kosong means 1 darab dengan 2.18 10 negative 18, you akan dapat nilai RH tu balik, right? Why you have to times Avogadro? Because you have to make sure it is always for 1 mole of electron. Get back to the definition for 1 mole of electron. Next, the Lyman series continuum limit is when the frequency is given as here, 3.29 times 10 15 second negative 1. So since the Lyman series continuum limit, the frequency is given, right? Of course, you can insert it here. H is the Planck constant. Planck constant ambil kat depan. This is the frequency given. Right, okay. So this is how to find the delta E. If you are given frequency at infinity, then you have to times with Avogadro constant. Then you'll have the same answer as the previous slide just now is 1312 kilojoule per mole. Dah tak ada jawapan lain since you insert with initial 1, while your NF kan final energy level is at infinity. So since you are inserting the same values, therefore you will have the same answer of 1312. The same goes here. You tak ada jawapan lain dah. 1312 only is the answer. This is referred as the continuum limit. Means the electron has been ionized here. You have learned the 4 Bohr's atomic postulates, which are number 1, electron moves in circular orbit about the nucleus, which we know that each orbit has a different energy level or energy state. In the specific energy level, boleh tak kita kira energy of the electron? Boleh. By using the formula of this, energy equals to negative RH divided by n square, which means n is the energy level. If let's say electron is located at n equals to 3, so that you masuk nilai 3 kuasa 2, which the energy of electron is fixed in value, or is it is quantized. Quantized, the word quantized here means having certain amount or certain value. The electron also does not release or absorb any energy when it is the ground state or at any particular energy level. So bila dia diam je, if let's say this is the nucleus, this is at N1, this is at N2, right, when the electron duduk senyap je dekat N equals to 2 katakan. So when the electron is circulating the orbit at n equals to 2, it is said to be not to release or absorb any energy. Energy is absorbed bila? When the electron move from lower to higher energy level, or when it is promoted or excited from lower to a higher energy level. And the energy is released in the form of photon, tenaga cahaya, when electron falls back or drop from higher to lower energy level. But it involved with two different energy levels. What to do is to use this formula of delta E equals to RH in bracket 1 over Ni square minus 1 over Nf square. Energy can be positive or negative. We know that if energy is absorbed, then the value will be positive. If the electron drops from higher to lower energy level, energy is released in the form of photons, so the sign of the energy is negative sign. This is when you have to calculate lambda. Right, so make sure when you have to calculate lambda, your RH, your Rydberg constant must be in meter negative 1. If you have to calculate energy, then you have to make sure your Rydberg constant must be in the unit of joule. And make sure also, if you have to calculate lambda, make sure it is N1, N2. Which N1, you have to always make sure it is smaller than N2. Dia mesti datang bersama package complete, N1 less than N2. Why? Because lambda must always positive value. When you insert N1 is smaller value, let's say 3 dan 5. Right, okay. So you have to make sure this is 3. Your N1 is 3, while your N2 is 5. So when you have higher value minus lower value, the value of lambda will be positive. That if is 3 and 5, right? Which you have to make sure N1 is 3, smaller value, N2 is higher value, which is 5. How about if electron drops from N equals to 5 to N equals to 3? So Ni ini nak masuk apa? Since it is drop from N5, so initial will be 5, while Nf will be 3 because it drops from 5 to 3. So what is the value of delta E? Of course, negative because it drops, jatuh. Makanya delta E will be negative sign. However, Bohr's atomic models have a few weaknesses, which are electrons are restricted to orbit the nucleus at a fixed distance, and it applies accurately only to one electron species only. It's like hydrogen, helium plus, lithium 2 plus. So, kita tak boleh discuss untuk calcium, untuk magnesium, untuk carbon with more than one electron species. So, it cannot account for atom with more than one electron. Cannot explain for the extra lines appear in the hydrogen emission spectrum. And it also did not take into account the wave nature of the particles. Sebab itu kita sebut Bohr atomic postulate. Kita tak sebut teori, kita sebut postulate. So what is meant by postulate? Postulate means the assumption that cannot be theory. Tiny particles like electrons can also have wave properties. Electrons should diffuse like wave into dimensionless space, and it should not be confined to a particular energy level. Ini memang jelas reject Bohr atomic model. Why? Because Bohr state that electrons mesti duduk setempat dekat orbit. But de Broglie state that electrons should not be confined to a particular energy level. This is the formula of de Broglie's, but it is not in the syllabus. Don't worry. So, ini tak ada dalam syllabus. Heisenberg uncertainty principle state that it is impossible to know simultaneously both momentum and position x of a particle with certainty. Reject Bohr's atomic model. And electron should not be confined also because its exact position and velocity cannot be determined. So they both, de Broglie and Heisenberg, have the same point. This is the formula of Heisenberg. But don't worry, it is not covered in the syllabus. So both of these are not covered in the syllabus. Both these tak cover dalam syllabus. So don't worry. State the disagreement between Bohr's postulates with Heisenberg uncertainty. So, ini adalah disagreement between they both, Bohr and Heisenberg. So, Bohr postulate assume that electron is orbiting the nucleus at fixed position. But Heisenberg's uncertainty principle states that it is impossible to know with certainty. Tak boleh tahu secara tepat dan jelas both position and momentum of electron at the same time. So, it rejects Bohr. This means that not only the precise position, but also the precise speed of the electron can be determined. Then, a scientist, nama apa? Nama Schrödinger, comes with the quantum mechanical model. He rejects Bohr's atomic postulate, but he used de Broglie's postulate with Heisenberg uncertainty principle to produce his quantum mechanical model of wave mechanics. Okay, so this is the nucleus. Electron is somewhere in the atom. Tak boleh confined at specific orbit. So Schrödinger also proposed that an electron behaves in a wave-like manner rather than just a particles. Thus, electrons are both particle and waves at the same time. Since electrons are waves, they do not remain localized in 2D orbit. That's all for 2.1.